Alrighty, hello everyone. Welcome to Lowell Observatory's interactive stargazing this nice April evening. My name is Claire. I'm an educator here at Lowell. And tonight I'll be helping you guys out with showing you some pretty cool images of what we can see tonight. So if you're new here, basically what we do is you can request things in the YouTube chat and we'll try our hardest to get your requests through. We usually only spend about half an hour on these videos just because it can get pretty cold here in Flagstaff, even though it is April. We'll try to get to all of your objects tonight, but to start us off, we have one called M46. So this is an open cluster with a nice little planetary nebula kind of in the center. So the skies are still a little bit light out here, but we can see just that little kind of like bubble in the center of the Malincam screen that we can see. I think we're gonna zoom in. Perfect. So it's just that little guy right there. And basically what a planetary nebula is that it's the dead stuff of a star. So this is all of the gas and dust of what used to be a star that is kind of just like slowly spread out in space and creates this nice little bubble shape around the star. But it actually isn't part of the cluster, we think. It's somehow behind or in front of it, so it's not actually part of the cluster M46, which is what we're looking at. But it's a nice little feature that we can see at the same time, so it kind of makes it like a two-in-one type of fun thing. But it already looks like we have lots of things to look at. So I'm going to kind of go out of order because one of you guys asked for M42, and I have hopes that it's still up, but we should definitely get it first because it is getting extremely low. We're moving away from the winter skies and going nicely into spring. So we'll do that one first, just so we can hopefully catch a nice glimpse of it before it gets too low, before the trees up here at Flagstaff. And also just to forewarn you guys, we're dealing with a little bit of wind, so if you see our image kind of shaking around a little bit and the star is getting a little bit blurry periodically, especially if we're using video mode, that is something that may happen. So just letting you guys know. Of course, we can't really control it, but here's M42. So we call this the Orion Nebula. This is probably one of the best and brightest of the Messier objects. That's such a great image. I love that nice red color that we're getting through there. So this is what we call a stellar nursery. This is where stars are born in the night sky. So all of this gas that you can see will eventually become stars in the future. And my favorite thing to look at is all of those dark shadowy bits that are kind of covering up and creating these cool little shadows and 3D gas looks within here. And I think this is a great image. So yeah, here's M42, that nice pink color that we're getting. So that looks pretty awesome. Nice. So we can go ahead and move on. Let's see. Let's go to M51, and then we'll try for another one after that. We're just trying to get the brighter objects first and waiting for the sky to get just a little bit darker when we try any of the darker stuff. So we're heading to one called M51, or the Whirlpool Galaxy. This is definitely my favorite Messier object in the entire night sky. It is near the constellation of Ursa Major, so basically the Big Dipper, except the constellation is actually bigger than that. And this is kind of a good example of what we call galactic cannibalism. So kind of what you can see here, we're still trying to up the exposure a little bit so it can get a little bit brighter, but you see these nice two kind of like nebulous dots. There we go. Now we can see a little bit more. So we see one pretty big galaxy with those nice spiral arms, and then we see one kind of coming off the side of it. So actually that bigger galaxy is kind of like slowly integrating that smaller one. Basically all that's left of that smaller one is just basically the core of that galaxy. And so over time, these galaxies are interacting with each other, and this is kind of a really great way to know how galaxies work in the sky, is just looking at different galaxies and kind of piecing together the puzzles. And again, we call this galactic cannibalism. So the big galaxy slowly eating the smaller galaxy, which is kind of cool. And I believe the bigger galaxy of M51, that nice bright one where we can actually see the spiral arms, we kind of call that like a grand spiral galaxy, which basically just means that we can see the spiral arms really, really well. So it's nice to look at through a telescope and nice to look at with astrophotography and things like that. So that's kind of what we call the Whirlpool Galaxy, but that looks pretty good. Always one of my favorites, definitely. So we have a request for the Jellyfish Nebula. So it's in Gemini, so we should hopefully be able to get it. However, this is a pretty faint object, so we'll at least try it. No guarantees that we'll be able to see a lot of detail in this, but we'll definitely give it a try. I don't think I've looked at this too much before. We're doing a search for it right now. We're using the catalog name for it because sometimes the PlaneWave software, which is what we're using, doesn't always have all of the names for us, but we're definitely going to give it a try. So again, this is a pretty faint object. We're going to start with a lower exposure and then maybe go to a higher exposure just to see if we can get anything, but we'll see what is there. For those of you following along, so this is hopefully the Jellyfish Nebula, but it also goes by IC443. So that's the kind of catalog name for this. So we can try and see what's there. So currently, if you see kind of those streaks of stars, we're still taking a picture while we move the telescope. So sometimes that's what happens. We don't always turn off the camera while we're still doing that. So it looks like there might be something there. There I see kind of like this bluish kind of green like haze in the image, which I think that might be at least some of it. Again, it'll probably be hard for us to kind of get a super detailed image just because we're only taking about like a 15-second exposure. So at least we saw like some of this nice blue gas, but I'm not sure how much else we'll be able to get just because it's probably a fainter object. A lot of that detail will need lots of time for exposure. But that was kind of a cool one. Let's see. So we have another one for Markarian's chain. Yes, that is definitely up for us. So that is in the constellation Virgo. The Messier object name or the Messier catalog name, some of them at least are M84 and M86. So we're going to go ahead and head there. And Markarian's chain is basically just lots of galaxies in the constellation of Virgo. And M86 and M84 in specific are part of the Virgo supercluster of galaxies, which is one of the big clusters of galaxies right next to us, basically. And so when you look in this area of the sky, you're just going to see galaxies upon galaxies upon galaxies. It's kind of really cool to keep searching for that and just seeing so many out there. They're really awesome. So it looks like we have them. These are more elliptical galaxies, I believe, so we won't be able to see a lot of spiral arms or anything like that, but they kind of look like those stars in the middle, but probably a little more fuzzy and brighter than the things around them. But it looks like we could at least get some of that going. So we have one kind of basically right in the center and then one kind of off to the right side for me at least. And so when you look at this with a telescope or with a longer exposure, you'll just see lots of galaxies in this area, and we call it Markarian's chain. So it's kind of just like one of the local groups to us. And galaxies, like stars, go into these big clusters. So we have galaxy clusters, and then just like we have star clusters, which is kind of cool. So these are basically just the really big structures of the universe. So galaxies, super big, come into galaxy clusters, which are pretty cool. And one of the closest ones is the Virgo supercluster. Again, basically right near and right in the center of the constellation Virgo. So I know we have some more things going. So another one asked for a planet. So we have Mars is up. That's basically the only one, I think. Jupiter, Saturn, and Venus are rise in the morning, so we won't be able to get any of those, but we can at least check out Mars while we have the chance. Mars is always a good thing to look at. So there it is. So our camera isn't super great at looking at these really bright objects like planets. This was a little bit better for things like galaxies and star clusters and things like that. So sometimes it's hard for us to get this really fine detail on the surface, especially because at this time, especially where Mars is in the night sky and where it is in its orbit and where we are in our orbit around the sun, it's not always like the best position for both of us to be able to get a lot of that detail. But that is Mars right there. And Mars is always special to Lowell Observatory. That was the thing that Percival Lowell wanted to study. So pretty close to us here. Mars is kind of the reason that Lowell Observatory is here, is because Percival Lowell wanted to look at Mars. So that is cool, but it's just that little guy in the center. We're trying hard to get a little bit more, let's see. Hard to get that detail just because it is getting pretty low for us, but also it's pretty windy, so it's going to be bouncing around a lot. But at least we got a planet, so that is Mars for us. Let's go ahead and go to M101. So I believe that is one of the pinwheel galaxies, yes, in the constellation Boötes, or at least near it. So M101 is such a great galaxy. It's one of my favorites besides M51. So it is a spiral galaxy, so we should be able to see at least a little bit of that structure with this guy. Looking through a telescope, this one's also pretty nice and bright, so it's a fun one to look at through telescopes as well. And yeah, let's see. So we're starting to get some through here, so we're upping the exposure just a little bit, but you can start to see those spiral arms and that nice little core of the galaxy right there. So we're zooming in a bit. So the core is right in the center. You can see kind of those very diffuse clouds. I think we're waiting for one more exposure in just about a second. There we go, a little bit better, so we can see the structure just a bit more. This is another nice galaxy where we're kind of looking at it face down instead of on the edges, like where we can get other galaxies. So kind of a weird way how I like to think about it is, say you had a plate of pancakes in front of you and you're looking down at the pancakes, kind of like standing up. You'd see like the circle of the pancake, but if you were to lift the plate up and look at the pancake on the edge, you'd see like a line. So with this guy, we're basically looking at this galaxy face down. In other galaxies, we can look at it edge on, and maybe we'll be able to look at another one of those tonight. But that's great. So far, you can see those spiral arms really well and that nice detail of the core of the galaxy. So that's M101, also known as the Pinwheel Galaxy. So another great spring galaxy to look at. That one's always really fun. Let's see what else we have. So we have someone who wants to look at M87, so we can definitely go there. That is in the constellation Virgo. So we're gonna head kind of back there. And M87 is really cool because this is the galaxy that we took the first black hole of. We, not as in Lowell Observatory, but we as in the Event Horizon Telescope, which is basically a bunch of telescopes around the world who looked at M87 and then kind of combined all of this data to essentially create a telescope the size of Earth. So black holes are incredibly small and we can't get them with a single camera like we are now, just because they're pretty tiny, despite how massive they are in terms of like their strength and their actual mass. They're actually like really small in terms of their diameter in the sky and the size. And of course, black holes don't emit any light, hence its name, black hole. So it actually doesn't emit any light. The only thing that we can see is stuff that goes around the black hole. And so that's kind of how we can see a black hole, though we can't actually see the hole itself. We can kind of just see the stuff that goes around that black hole and creates energy for us to see it. But this is the galaxy that we did that with, I think, just a couple of years ago. So it's pretty recent that we did that. But here it is. So M87 is an elliptical galaxy. So it's kind of just that nice bright blob in the center. Elliptical galaxies are kind of like football-shaped galaxies. They don't have a nice spiral structure like other ones, and these are some of the biggest galaxies in the universe. So these are well developed. They're also pretty old. Usually there's not a lot of star formation going on in them. So these are some of the oldest that we can see. Usually these ones also have pretty massive black holes in the center as well. So that's kind of what we're looking at here, but always an exciting one. Again, this is the one where we took the first picture of the black hole. So I know someone asked that, is it possible to see a black hole? So hopefully I answered that question, but if you want me to elaborate more, just let me know. So someone also asked if we could see the Orion Nebula. So we did do that one in the beginning. So we already showed that one. Someone else asks for us to look at the star Sirius, so we can go ahead and go there. That's nice and bright, and we should definitely be able to get that one. So Sirius is the brightest star in the sky. It's in the constellation Canis Major, which is the big dog. So Canis Major and Canis Minor are two constellations that we usually refer to as part of the winter hexagon. And these two constellations follow Orion the hunter in the sky as kind of, sometimes they're referred to as his hunting dogs. But Sirius, the star, is the brightest star in the sky. Now, it's kind of funny because some people might think that the North Star is the brightest star in the sky, but in fact, it's not. The North Star is like about the 50th brightest, pretty close to that at least. And Sirius is usually almost like due south, so it's basically in the opposite direction. So don't follow that advice that the brightest star in the sky is north, because it's definitely wrong. But here it is. So Sirius is a binary star, but I don't think we'll be able to get the binary pair just because it is really small and tiny really next to it. But, well, kind of. You can kind of see like a little dot just coming off the side. I think that's it. But it is hard because Sirius itself is such a bright star, and it's also really close to us. And so kind of getting that little binary pair is tricky sometimes. But that's where it is. Sweet. So I know we have many more coming in. Let's see. So we have someone asking for, they just asked for something in Virgo. So we did look at a couple things already in Virgo. If you have a specific galaxy that you'd like to look at in Virgo, or something specific in that constellation, that would be helpful for us just to know, so that we can get something that you wanted. But we have already looked at some of them. Let's see. Let's go ahead and head to one of the requests, and then I can get to some of your questions. So Ernie Jacobs asked, how about M97? So let's go to M97. And we looked at M46 already. So M46 was our first object. So just letting you know. So let's go ahead and head to M97. I'll get to some of your other questions. So Zach Davies asks, what is the farthest galaxy that people can see with their naked eye? Usually it's the Andromeda Galaxy, which is about 2.5 million light years away. That's the brightest. It's definitely a naked eye object. There are a couple that are kind of on the edge of being able to see with your naked eye, but I would honestly say, at least for me, someone who has to wear glasses, and generally, even Andromeda seeing with your naked eye is hard because it is pretty faint still. So I would say that's probably at least the most correct answer I can give you. Looks like we have the Owl Nebula in here. So the Owl Nebula is another planetary nebula, I believe. It kind of like is supposed to look like an owl's face, I believe, or something to do with an owl, which is how it got its name. But this is pretty close to the constellation Ursa Major. And it's like this nice little blue turquoise guy, and it's actually one of the bigger planetary nebulas that we can see. And so I really like the color of this, and I kind of like how the shading is different as you get to the center, and I believe that's the white dwarf star that we can see right in the center there. So white dwarf star is basically the dead core of a star. So after a star like our sun runs out of fuel, so stars right now are, or at least our sun right now, is fusing hydrogen. And then after it runs out of hydrogen to fuse, it'll go to helium, and then it'll probably go up to about carbon in the periodic table. But after that, our star just isn't strong enough to keep going after that. So it'll kind of just push all of this gas away. What will be left is a white dwarf star. So usually in the centers of planetary nebulas, there's a white dwarf remnant, which is kind of like the central star that is still ionizing all of this gas, or exciting the electrons around all of these atoms in the gas, so that we can see it with our telescopes and binoculars. So that's nice and pretty for us. So yeah, let's see. Let me check on our requests. Sweet. We already showed Sirius. Sirius B is pretty faint. So we did try to get that when we first looked at Sirius. It was kind of hard to do it. It is pretty windy out tonight, and so our telescope is just dancing around just slightly, and that certainly doesn't help. We have another request for Zeta Reticuli. That is too far south for us, so unfortunately we will not be able to do that one. We have another request to see a supernova. I'm gonna wait back to here to see if there's something that we can, but I don't know if we can. So we will try that in a sec. I guess we can. Let's go ahead and try for M1. Hopefully it's high enough up. If not, then we can try for another one. So in terms of seeing a supernova, we're going to look at a supernova remnant instead. So one of the most famous ones in the sky is, of course, M1. So this is called the Crab Nebula. So it's getting pretty low for us on the horizon. So I think some of that like blue stuff going on is maybe I'm not entirely sure, just extra light that we're gathering from somewhere, but we can at least see the Crab Nebula in the center here. So if you kind of see that little fuzz patch in the center, that's basically all of the gas of what used to be a star that exploded some thousand years ago, or many thousands of years ago. So ignore that kind of blue stuff and instead look at the thing kind of in the center that's a little more pinkish to me, kind of like a little more purple, and definitely white in the center. And again, this is pretty low. I think the light is from the telescope, the blue stuff. Sometimes it gets that way. And when we point in certain directions, we're basically pointing almost right at the horizon, because I know this is definitely low right now for us. But M1 is the first catalog one in Charles Messier's catalog, the Messier catalog. But yeah, this is the most famous supernova remnant that we can see. Kind of if we zoom in just a little bit, you can see some of the structures that make it different from a planetary nebula, which is kind of interesting. So we can, to me, it kind of looks more like a spider's web, where it looks like there's like these things kind of like poking out into the center, which I think are just testament to the fact that this was such a violent explosion in the night sky. So that's how it looks different to me from a planetary nebula, because that's what makes it exciting. And at the center of this, I believe there is a neutron star called the Crab neutron star, or the Crab pulsar. So that's what's at the center of this. So when a supernova happens, basically we have two basic options of what can recur after a supernova. So we not only have all the stuff of what used to be that star, but we can usually get a black hole or a neutron star. So that's kind of how those things form in the universe, is from the massive implosion then explosion of these massive stars. So in the center of this one, it is a neutron star. So it looks like we have another request. Let me scroll down. Let's see. Someone asked for Rigel Cantarus. So, I think I already said that's too far south. That was another one. So Rigel Cantarus is too far south for us, so we won't be able to get that. We have another one for while you're in the north is the double star still up. So for us right now with the plane wave telescope, the Godot building is still in the way, but we can move to a different double star. So we can move to one in the constellation of Cancer called Iota Cancri, if we can go to that. So Iota Cancri is another binary star in the sky. To me, it kind of looks like Albireo. It's like the spring Albireo, because there's a blue star and a red star. So hopefully we can grab that, but I'll give the telescope operators time to look for that, because I think we have to do an extra search. So we'll go there. And Steve asked, is this a live view of what's out tonight? Yes, so we are taking your requests from the YouTube chat and trying our hardest to look at what you want. And so this is all live. We're using our plane wave telescope with a video astronomy camera attached to it. So this allows us to take really short exposures of the night sky and still get pretty good images for you guys. So we can keep moving quickly and you don't have to sit here for a couple hours while we try to get a really nice exposure. So that's kind of what we're doing. So it looks like we got it. So it's just these two little guys in the center. So again, this is a binary star. So if we could look at this this pair for about 650,000 years, that's actually how long it takes for these two stars to orbit around each other. There's some like couple billion miles away from each other. So despite these orbiting each other in the night sky, they still take so long to do that orbit, and they're still incredibly far away from each other. But we think about 30 to 40% of the stars are actually binary stars in the sky, which is kind of cool. So this is one of my favorites. Again, we have that tiny little star kind of towards the bottom left. That is the blue star, and then the bigger one is going to be a little more orange or yellow color. The colors of stars can tell us a lot about what that star is. So really generally, blue means young and hot, and red or orange means older and colder. But that is obviously a simplification, but it kind of works for this guy. So we have one for M104. So that is the Sombrero Galaxy. So we can go ahead and head there. This is a really awesome one. There's another question, how long have I worked for Lowell? So I started off as a volunteer basically April of 2019. So counting volunteering, that is about 2 years, but with being an actual educator, it's been about a year and a half. So I'm probably still considered a newbie in a lot of regards, but I absolutely love it here. I enjoy this so much. So while we're moving to the Sombrero Galaxy, this is close to the constellation Virgo and also close to the constellation Corvus in the sky. But back to my pancake analogy, this time we're looking at this galaxy like a line, so not face down. Instead, we're looking on it at its edge. So that's nice. So we can see the really nice bright galactic center, and then we can see kind of like that line kind of going like right in the middle. So that's what we're looking at now. And the Sombrero Galaxy is really special to Lowell Observatory because with this galaxy, Vesto Slipher, one of our amazing astronomers here back in the 1920s or so, took one of the first really important redshifts of this galaxy. So essentially with this galaxy, he took some of the first evidence for the expanding universe, and Edwin Hubble later used some of Vesto Slipher's data to come up with the theory that most of us probably know about, the theory of the expanding universe. And again, Vesto Slipher was one of the first people to actually take real data for that using our historic Clark telescope, which is almost 125 years old, I believe. So that's kind of special to us, is that there's some pretty rich history here with this galaxy in specific, which is really cool. So that's the Sombrero Galaxy. I think it gets its name, like if you were to imagine flipping this image like 180 degrees, so basically upside down from where it is, it would look like the sombrero hat or something like that. But it's pretty cool. So we can probably get a couple more things in, but we are running out of time, so I'll try to get the rest of your guys's. So we have a request for the star Arcturus. So yep, that's totally up. We can go there. Arcturus, I believe, is the fourth brightest star in the sky. It's in the constellation Bootes, and this is another nice red giant star. Yeah, nice. So we can kind of see that red color, but it's hard to get when we're taking like a shorter exposure. Let's see. Yeah, that looks pretty good. But again, Arcturus is about the fourth brightest star in the sky. It's pretty important. Arcturus is one of the brightest stars that comes up in the springtime. For us standing out here on the Godot deck in the deep dark winter, when we see Arcturus, we know spring is coming and hopefully warmer weather on the way, so that we don't have to use our little hand warmers in our pockets every night. Always nice for us. But that is Arcturus, one of the bright stars. Again, it's a red giant star as well. So we have another guy. Let's see, M65 and M66. Yep, that's part of the Leo triplet, so we can go ahead and go there. Leo is almost straight up ahead of, basically at zenith for us, so we should be able to see at least M65 and M66 together. I know one of them will be towards the edge, but we can definitely get both. And these are nice, pretty detailed galaxies that we can see in the night sky, and they're some of the brightest as well. So these are pretty cool. Again, they're part of what we call the Leo triplet, I believe. This is kind of like a famous, not necessarily like an actual galaxy cluster, but they just appear to us as if they're kind of in a cluster. So it looks like we're getting a little bit more of an exposure going, just so we can get some more of that detail. But again, it is kind of windy tonight, so we're trying our hardest to get both of those. But at least we have something here. So we can see one right in the center, nice bright core, and then kind of one off to the edge. We can see the spiral arms just a little bit better. We're kind of viewing these galaxies in different orientations, but I think it's really cool. It's very rare to actually see two galaxies within the same field of view. So this is always awesome to look at because it is very rare that we can do this. So that's always cool. So we have another one for Aldebaran. I think we'll be able to get it. I know Aldebaran's getting really low though. So let's try. It will be pretty low though, but it's a bright star, so we should be able to get it unless it's in the trees, but I hope it's not. It might be. Oh, there we go. We just had to zoom out. So it's that little guy in the center. I think we're just going to up our exposures a little bit so we can get it a little bit brighter. So that's Aldebaran. This is in the constellation Taurus, the Bull, and this is another pretty famous red giant right now. And Aldebaran and Mars are pretty close to each other. And so I always like to use it as a comparison of how to look at planets in the sky and then how to look at these stars in the sky and kind of be able to tell with your naked eye what the difference is between how a planet looks and then how a star looks. And I think that's kind of cool. But we are pretty low to the horizon, so it might look a little bit weird for us, but that's that guy right there. So let me, there's one more request so far. NGC 40, so that's the Bowtie Nebula in Cassiopeia, and currently Cassiopeia is getting pretty low, and it's also behind the Godot building for us. So unfortunately, we won't be able to get that. We have another question. What are the requirements to be a volunteer? I think you have to be at least 16 years old, and kind of just like basic things for any job that you have to like pass a background check and things like that. But if you have a passion for astronomy, even if you don't know constellations and how to find them in the sky, even if you know very little, we'll teach you all of this because we love our volunteers and they're incredibly helpful to us. So you can find information about becoming a volunteer on the Lowell website under employment, I think, or one of the tabs. And there's an application there, but volunteering was some of the most fun I've had for sure. So I highly recommend if any of you guys are interested to go check it out. And you need little to no knowledge. And again, we'll teach you everything that you need to know because that's part of the fun. So let me just make sure I didn't miss any questions. But it is about 8:30. So we're gonna start wrapping up. So if you have one last thing you wanna look at, put it in now. But if not, we will do that. So we have one, I think one of the first questions that I totally skipped over. Of all your telescopes, is there one that you use your Godot scope and camera? Yeah, so we're currently using what we call the plane wave telescope. So that's the company that makes them. So we're using our 14-inch plane wave. And so that's what we're using. And this is all computerized. So this telescope doesn't even have an eyepiece attached to it. So it's basically like a small little instrument cube, and we can attach different things onto this telescope. And these are research grade telescopes. So this is what we're using now. They're really helpful because they move pretty fast and they have pretty reliable software. And so we love these, and it's also kind of the nicest for us to use these for. But I think that is what you asked for your question. But currently it doesn't look like we have any more requests for tonight. So I'm gonna go ahead and say thank you all so much for tuning in with us tonight, and I hope you had fun, and we've looked at some pretty cool things tonight. We'll be doing this next Tuesday as well, so tune in there. I think we're starting a little bit later, so next time we'll be starting at 8:30 just because we wanna have slightly darker skies when we start. The sunset has been happening later, and we want to make sure we can actually see things when we start. So I think the next time we will be starting at 8:30, just to let you know, but you can set a reminder on the YouTube channel, and that should be good. So thanks all again for tuning in. Hopefully I'll see you guys next week. And yeah, have a good night. Thank you.